Good evening, everyone. Myself, Syed Shahab from EC Second Year, ISL Engineering College. Today, today I am going to give a seminar on Maxwell equation static. Now, we'll get to know the introduction. Maxwell equation describe how electric charges and electric currents create electric and magnetic fields. The first equation allows you to calculate the electric field created by a charge. The second allows you to calculate the magnetic field. The other two describe how field circulate around their sources. Now, Maxwell equation predict that static electric fields, that is, fields that do not change with time, are produced by charges. Charges are sources and sinks of field lines. Static electric field lines begin on positive and end on negative charges. Static electric field lines never form loops. The static electric field is a conservative field. If you do work on a charge against the static electric field, this work is stored as potential energy. The potential energy is a function of position only. You can let the electric field to work to recover the energy you expended in moving the charge. In statics, Maxwell equation for the electric field combine to give you Coulomb's law and the principle of superposition. Everything else is just vector addition. Now, in statics, Maxwell equation for the electric field combine to give you Coulomb's law and the principle of superposition. Maxwell equation predict that static magnetic field are produced by moving charges or currents. We got to know that statics is Maxwell equation for the electric field combined to give you Coulomb's law and the principle of superposition. Maxwell equation predict that static magnetic fields are produced by moving charges of currents. There are no magnetic charges and therefore no sources and sinks for magnetic lines. Now, we will go to Maxwell equation for statics. There are two equations, that is the electrostatic equation and the integral form of electrostatics. Firstly, we will get to know what is electrostatic equation. If we consider the static case, that is constant with time, of Maxwell equation, we find that the time derivatives of the electric field and magnetic flux density are zero. Thus, Maxwell equation for static field become these four equations. Look at what has happened for the static case, but just for the static case, Maxwell equation decouple into two independent pairs of equations. These equations. Now, the first set involves electric field and charge density only. These are called electrostatic equation in free space. These are the electrostatic equation for free space, that is a vacuum. Note that the static electric field is a conservative vector field. Do you see why? This, of course, means that everything we know about a conservative field is a true also for the static field. Essentially, this is what the electrostatic equations tell us. The static electric field is conservative. The source of the static field is charge, that is this equation. In other words, the static electric field diverges or converges. The chapter from which we have taken the data deal with, in that 4th, 5th and 6th chapter deal with electrostatics, 7th, 8th and 9th chapter deal with magnetostatics. These equations are called the magnetostatic equation in free space and relate the static magnetic flux density to the static current density. Now, first we have learned about the electrostatic equation. Now we will go to the integral form of electrostatics. We know from the static form of Maxwell equation that the vector field is 0 at every point r in space, that is delta into Er is equal to 0. Therefore, any surface integral involving the vector field will likewise be 0. But using Stokes' theorem, we can also write this equation. Therefore, the equation is the integral form of this equation. Of course, both equations just indicate that the static electric field is a conservative field. These equations you will see here. Likewise, we can take a volume integral over both sides of the electrostatic equation. But wait, the left side can be rewritten using the divergence theorem, and we know that the volume integral of the charge density is equal to the charge enclosed in volume V. Therefore, we can write an equation known as Gauss' law. You can see the equations here. Now, let us know what is Gauss' law. Gauss' law: the total of the electric flux out of a closed surface is equal to the charge enclosed divided by the permittivity. The electric flux through an area is defined as the electric field multiplied by the area of the surfaces projected in a plane perpendicular to the field. Now, what Gauss' law says? What Gauss' law says is that we can determine the total amount of charge enclosed within some volume V by simply integrating the electric field on the surface S surrounding volume V. Now, we got an idea about Gauss' law and what Gauss' law says. After that, summarizing the integral form of the electrostatic equation are this. Note that these equations do not amend or extend what we already know about the static electric field, but are simply an alternative way of expressing the point form of the electrostatic equation. We sometimes use the point form of the electrostatic equation, and we sometimes use the integral form. It all depends on which form is more applicable to the problem we are attempting to solve. Basically, Maxwell equation Maxwell equation are four, that is Gauss law, Gauss law for magnetism, Faraday law, Ampere's law. Now, Gauss law, electric charge produced on electric field. Gauss law for magnetism, there are no magnetic monopolars. Faraday's law, time varying magnetic field produce an electric field. Ampere's law, steady currents and time varying electric fields, the latter due to Maxwell correction produce a magnetic field. From this we get to know an idea about Maxwell equation for. From this all we got an idea about Maxwell equation static, that Maxwell equation static what deals with which equation, the electrostatic equation and the integral form of electrostatic. These are the basic equations which are to be followed in Maxwell equation for static, and it also is useful in many ways. Thanks for watching my presentation.